Hi guys, today we're going to be doing a problem from the textbook that is on solubility. So it's on page 22 and it is number 54. So the problem reads, potassium sulfate has a solubility of 15 grams per 100 grams of water at 40 degrees Celsius. A solution is prepared by adding 39.0 grams of potassium sulfate to 225 grams of water, carefully heating the solution and cooling it to 40 degrees Celsius. A homogeneous solution is obtained. Is this solution saturated, unsaturated, or supersaturated? The beaker is shaken and a precipitation occurs. How many grams of potassium sulfate would you expect to crystallize out? So, the first thing to do with this problem is to write out the givens that they give you, because it's a pretty big paragraph and this helps you organize what you have to do. So, first I would write out that there is 15 grams of K2SO4 per 100 grams of H2O at 40 degrees Celsius, because that's kind of your standard ratio in the problem, and that's the solubility, and that's given to you in the first sentence of the problem. And then in the darker blue, we also can write out that there are 39.0 grams of K2SO4 added to 225 grams of H2O. So now that we have our givens written out, we can start by solving this problem. So this problem is we have two steps. We need two problems we have to figure out. The first one they ask us to solve is the solution saturated, unsaturated, or supersaturated? So in order to do this, first thing we need to do is set up two ratios. So the first one is we want to look at the 15 grams of K2SO4 per the 100 grams of H2O. And when we do that, we get 0.15, so that's kind of the percent of K2SO4 per the amount of H2O. And then the other one we want to look at is the 39 grams of K2SO4 in the 225 grams of H2O. So once we set up those two ratios, the second one we get 0.17. And with that, we know that the first ratio we set up, that's the standard one that we're going to be comparing it to. And we know that 0.15 is less than 0.17. And since the 0.17 is greater, that solution is supersaturated, because the number is bigger than the standard solubility. So now let's solve the second problem they ask us. And that problem was, how many grams of K2SO4 would you expect to crystallize out? So the first thing we need to do is write out an equation. So we know that in the solution that we mix in the problem, that there's 39 grams of K2SO4, and they're asking us of the K2SO4 how much do we expect to crystallize out. So we can do 39 minus x, where x is the amount that we expect to crystallize out, over the 225 grams of H2O. And you can see that here on the left of the equal sign. And then we set that expression equal to the 15 grams of K2SO4 divided by the 100 grams of H2O. And then after that, we cross multiply. And then after we cross multiply, we do some algebra and we solve for x. And once again, x is equal to the amount of K2SO4 that we expect to crystallize out. And we should get 5.25 as our answer, but we're not done yet. You cannot forget about units and sig figs. So you should get 5 grams of K2SO4 that you expect to crystallize out, and you round off to one significant figure because in the problem, the least amount of sig figs is 1, so that's what you would round off to.